Okay, we're making some headway here in section 1.7. We already talked about linear inequalities and three-part inequalities, and we're working on quadratic inequalities right now. We had one example already, and now we have one more. It's example 3b that we'd like to work through. The key here is to go through this five-step process to get to the solution. And so if you'd like, you might pause the video and try to work this problem for yourself. So what we're going to do is set up our quadratic in a special form. And so that special form means we need 0 on the right hand side, and we need the factored form on the left hand side. So the way to begin this problem would be to go ahead and multiply out x times x gives x squared, and x times 1 gives x. And then we can subtract the 30 from both sides, and we have x squared plus x minus 30 is less or equal to 0. That means we now have 0 on the right side, we have a positive leading coefficient on the left side, and then the factored form would just be x plus 6 times x minus 5. We're moving a little faster through the factoring now. We've been practicing that quite a bit throughout this chapter. Hopefully you feel confident getting x plus 6 and x times x minus 5 pretty quickly. Okay, so let's call that step number 1. And then step number 2, we're going to replace the inequality symbol with an equal sign, and we're going to solve that equation. And so now we just want to solve x plus 6 times x minus 5 is equal to 0. And so two solutions here. We're going to have x equals -6 or x equals 5. In step 3, we want to identify the intervals determined by those solutions. And so really all we're trying to do is get started on step 4, right? We need to identify what the intervals are in step 3 so that we can test those intervals in step 4. So if you can already see what the first interval is or what all the intervals are, then you might even skip step 3. But let's go ahead and write it out. So we have two cuts, if you will, in the number line to represent the two solutions to the quadratic equation. And so the smaller solution for the equation is -6. So it would go over here on the left, and the larger solution is +5. So it would go next. It would go over to the right. And then can you see that the first interval here is going to be from -∞ to -6, and then from -6 to 5, and then 5 to infinity. So I won't write that down right now because I'm going to write it down in just a moment here when I get to step 4. The columns of the table will be test interval, and then test value, and then what is the sign of x plus 6 times x minus 5. So again, we can look back at this number line in part 3, and we can think from -∞ up to -6 would be the first interval to check. And the next interval would be -6 up to 5, and then from 5 to infinity. What's a number between -∞ and -6? Well, lots of them to choose from. I'll probably just choose -7. On the next interval, from -6 to 5, I'll choose 0. And then from 5 to infinity, I'll choose 6. So now let's go ahead and plug in to this expression with -7. When we see -7 plus 6, that's a negative number. That's -1 multiplied by the next factor is -7 minus 5. That's another negative. And so the result is a positive. And again, we don't need to know that it's -1 times -12 to make +12. We only need the positive sign and not the 12. And so let's just keep track of the signs and then remember the rules for multiplying the sign numbers together. Okay, 0 plus 6 is positive, 0 minus 5 is negative, so the result is negative. And then when we plug in 6, we get a positive multiplied by a positive, and so the result is positive. And so we have the answer in front of us. We just need to interpret it. Let's go back to our first step. Here's the problem we were given, and then here's the equivalent form that we've been working with ever since. And so what we're asking is, when is the product less than 0 or equal to 0? We already know when it's equal to 0. That's at those at the edges of those intervals at -6 and 5. And then when is the product less than 0? Well, less than 0 means negative. So the product was negative just on this one interval here in the middle from -6 to 5. And so the conclusion would be from -6 to 5. And again, since it's less or equal in the problem, we're going to put brackets around the solution. I suppose you could have put brackets over here in step 4, although that's not really accurate. We're not really testing on the closed interval. We're testing on the open interval. We already know what happens at -6 and at 5. We're testing in between over here in step 4. So that's a small detail. The most important thing is to make sure that your answer is correct in terms of parentheses versus brackets.